Okay, this is Paul Geyer, and I will be the presenter today for this PDH Source webinar, An Introduction to Construction Activity Hazard Analysis. Just a quick little point on housekeeping here. The way we, excuse me, proceed with the webinars with PDH Source as I move forward with the discussion for 50 minutes, and then we take a 10-minute break so we can answer any emails that you may get or that sort of thing. So, and then come back, do another 50 minutes. And this is just a 2 PDH or 2-hour webinar, so we'll just go through that cycle twice. And let me get used to the controls here with Zoom. The construction activity hazard analysis is a bit of paperwork that was created, you might say, out of the OSHA programs and mindsets and what they do. And the whole point is to minimize, perhaps prevent injuries on the construction job site. And this is something that is not always the first thing that you're thinking about when you're involved in a construction project. You're focused on safely, properly, and expeditiously. And you instinctively, if you're a typical construction person, you just don't think about the hazards associated with construction activities. And so you may think that, well, this is, and this being a creature of OSHA, it has spread out into the other federal agencies and is now part of the way of doing business if you are working on a construction contract for a federal agency like the Corps of Engineers or NAVFAC or the Department of Energy, anything like that. And so it's something that you need to pay attention to, some paperwork that you need to do if you are working on a federal contract. And so the initially, your initial reaction may be, oh, just more paperwork. But actually, it's a pretty useful tool. And the reason that it's a pretty useful tool is that it forces you, assuming that you are all pretty much involved in the construction end of things as compared to the design end of things, it forces you to think ahead of time about the risks that may be associated in specifically what your specific project is involved with. And it also provides a useful tool to use during the construction process for the construction manager, the construction supervisor, and the workers on the construction job site to actually use. It's a piece of paper that they have available to refer to on a daily basis as they go about their tasks. And it serves as a reminder to them, oh yes, I'm going to be doing this particular task today. These are some of the risks associated. You might fall in the excavation, et cetera, et cetera. Somebody might drop a hammer on your helmet, things like that. And it forces you to think about these, if you use these tools, these paperwork tools appropriately. It's a good reminder, if you will, on a daily basis for everyone involved in the construction process. So it requires some work, some thinking up front before you get started on a project. Generally speaking, this effort, this thinking is going to have to be put in by the whatever you might call them, the construction manager or the construction supervisor or the foreman or whatever on the project. But then the result of that advanced upfront thinking is going to be some paperwork, pieces of paper that are then available as tools for the construction supervisor, construction manager, and workers to use on a daily basis in the prosecution of the project. And it is, this paperwork is a living tool, if you will. In other words, the construction supervisor, construction manager puts thought into what's involved in this upcoming project ahead of time. But then partway through the project, he or she becomes aware that, oh, there's this other problem of getting, an electrical injury that I'm now aware of. And so you can modify the paperwork as you go along. So this activity hazard analysis, construction activity hazard analysis, is a living document during the course of a project. And also it can be useful if you want it to be as a historical and archive piece of paper for use perhaps in the future. In other words, you've got an excavation project that you're working on now. You've gone through the activity hazard analysis process on this project. You, at the end of the project, you file the paperwork away, perhaps annotated with your things that you noted during the course of the project. Well, during this project, we did this and that worked pretty well, and this didn't work so well, and so on and so forth. All that goes into an archive in your company or agency's files and is available in the future. So another excavation project comes up down the line, you can, if you use this tool appropriately, go to the archive and look up the excavation projects, and you can see that on these prior projects, this is how they prepared their activity hazard analysis paperwork. And so I can use that as a guide in preparing the activity hazard analysis paperwork on this new project that I'm going to be the construction supervisor on, or the construction manager on. So this is not rocket science, but it does require a bit of time and effort and thinking. And so what this I'll be talking about today is, to a degree, is a 6-step process for preparation of an activity hazard analysis piece of paperwork for a project. So these are the chapters in the book, the things that I'll be touching on today. Contractor risk management process, what that is in a generalized way. And then we'll walk through the 6 steps that you go through on a project to prepare an activity hazard analysis for your upcoming project. And then chapter 3, we will be looking at some potentially hazardous activities on construction projects. Now, this isn't something that you need to memorize or anything like that, but it's something that you can kind of use as a checklist for future projects. I've got this kind of a project. Let me see. Let me look at this checklist here. And oh yes, on this kind of a project with these kind of things going on in the field, these are the accidents that might happen, the hazards that might pop up. And then I'll point you to some other materials that have been prepared by federal agencies, because again, this is a creature of the federal government, OSHA, and then it has now permeated out into all of the construction activities in federal government, Corps of Engineers, NAVFAC, GSA, et cetera, et cetera, et cetera. And it's also now permeating out into the other public agency work at the state and local levels, and even private companies to a degree are beginning to become aware of it and incorporate it into their way of doing things. And quite candidly, the reason with private companies that they're incorporating it into their processes is because of their insurance. Their insurance companies are insisting on this kind of an approach to risk management. So it's creeping out there into the industry. Okay, now after all of that, just by way of introduction, who I am and what I've been doing for the last few decades. For 35 years, I was a straight ahead designer, cranking out drawings and specs for the construction of buildings and quite a variety of infrastructure. And so I really, that's what I am. I'm a designer. I'm not a construction person, other than, of course, the role that the designer has in the construction process, which may be site inspection of the work to assure conformance with the drawings and specifications. Contractor, the builder, has questions about what do you mean by this on the drawing. So he issues a request for information, and the engineer goes out on the job and says, well, okay, these particular nails, you hit them with the hammer on the flat end rather than the pointed end, and that's the kind of thing that you no, I'm joking, I'm being silly. Okay, so anyway, 35 years, straight ahead designer, got registered in a few different things along the way. And then actually for an additional 9 years after that, I was out of the design business in what might be called the public policy business, where I was a principal staff advisor to the California legislature on capital outlay and infrastructure issues, anything associated with facilities design and construction. And there could be, and occasionally were, occupational safety type issues that would crop up, and I was supposed to be the expert that they would turn to. So anyway, that's what I've been doing. Again, I've been basically a designer, not a construction person, but obviously associated with pretty familiar with the construction business. So first of all, the general concept of contractor risk management. And your companies or your agencies, and particularly your insurance companies, are concerned about this because when injuries occur on the job site, that increases the cost of doing business. Workers' compensation insurance companies come into play. And so over the years, there has been increased emphasis in the industry on risk management, reducing, just plain and simply reducing workplace injuries on the job site on construction projects. And so the generalized concept of a risk management process involves first the identification of the risks associated with a specific construction project. And these risks can be totally different. If you're digging a trench and laying a pipeline, there's one set of risks that are involved, injuries that might happen. If you're framing a house or a building or something like that, there's another set of risks. If you're with the electrical work, obviously a completely different set of risks associated with that kind of work, and same thing, mechanical, structural, et cetera, et cetera. And so step number one in a generic contractor risk management process is identification. What are the potential risks associated with this particular activity on this particular job? And this particular activity is almost in a way means the different subcontractors, because you've got one guy doing the plumbing work, guy or gal, and you've got somebody else doing the electrical work and this sort of thing. So the risks are different, for, generally speaking, for these different trades. And then an assessment of those risks after you've identified them. The risks on this pipeline excavation project are that the walls might cave in and trap someone in the excavation or cover them up, this sort of thing. And so step number two then is assessment of those risks. Which ones are fairly or potentially fairly likely to happen? And if they happen, how serious are they? Now, you can think of a lot of hazards that can take place out on the job site. A carpenter is hammering nails and he hits his thumb with the hammer. Well, that's probably not going to be terribly serious. So the consequences of that kind of a risk or hazard materializing, it's not that great. But on the other hand, if it's a multi-story building and you're doing framing on the top floor, there's the fall risks, and there the consequences of an incident like that are very serious. Serious injuries, maybe even fatalities. And so you identify generically in a risk management process, identify the risks, assess them for their two ways, for their potential to occur, and then the consequences of an incident if it does occur. So a particular type of incident the chances of it occurring are limited. So that kind of decreases its importance, you might say. Other incidents are more likely to happen, so that increases your concern about those incidents. And then the consequences of an incident. Even though a particular type of incident is not likely to occur very often, the consequences of the incident are quite high. Serious physical injury, fatalities, this sort of thing. So it's about, you've got to balance the two of these together to determine the priority that you put on these particular risks that you identify, preventing these incidents from happening. And that's kind of an important concept to keep in mind. So you identify the potential risks, you assess the likelihood that they will occur, and you then assess the seriousness of their occurring, and then you balance the those two assessment values, you might say, together to arrive at, in your own mind, in a rational way, a priority for preventing that type of incident from happening. And because it's just the way things go, you have to prioritize what you put your time and efforts into on a project. You don't have an infinite amount of time, and of course you have to balance these safety risks with the fact that you've got to get this project built on time and within budget. And then once you've prioritized the risks of these different incidents that you have identified, you then allocate your resources to preventing them. Now, some of the resources may be the provision of appropriate personal safety equipment. But other resources may be your time and energy that you put in to, for example, inspection. Okay, I've got a risky activity that's going to be going on out here on the job site. I need to go out there in the morning, make sure everybody is wearing their hard-toed shoes, hard-toed shoes. I was going to make a silly joke about a hard frog there, but I won't. And wearing their, their hard hats and gloves and knee pads and other things. And that if you're involved in some activities that are off the ground, high-rise or mid-rise buildings, the appropriate barriers have been constructed, this sort of thing. So the resources that you have to apply to these risks include not only the personal protective equipment and this sort of thing, it involves inspection, and then it can also involve procedures that, okay, you people are going to be out here doing this today. Here is the sequence in which you need to undertake this work. You tell them that in the morning, and then it may be such a potentially serious incident that could occur that you you decide that it's a good idea to go out there another couple times a day and just check and see that everybody's doing what they're supposed to do. So that's kind of the fundamental picture of a contractor risk management process. Identify the hazards, the things that can go wrong, assess those hazards in terms of their likelihood that they will occur, because some things it's not likely they're going to happen very often. Others, yeah, that happens all the time. So assess the likelihood that they will occur, and then the seriousness if they do occur. And then prioritization, and this is not something that you can do by filling in the numbers on a formula or something like this. This is something that you have to make, you as a construction manager or construction supervisor, or even a worker on the job, need to take a look at the likelihood that this type of an incident will occur, and uh, consequences of that incident, and then you use your judgment to balance those two, and you go through and you do that on all of the hazard potentials associated with whatever your activity is. And you end up, you might say, with and you could probably, in a way, if you want to, as your own methodology, use kind of a point system, 1 to 10. There's a 1 to 10 possibility that this particular hazard will be realized. There's a 1 to 10 seriousness of the consequences of the this particular incident or hazard taking place. You add the two numbers together and you come up with a rating, if you will, for that particular hazard. And you can then just stack them up in a list, and that's your priorities. So a numerical approach like this can be helpful in visualizing the priorities, and these numerical approaches can sometimes kind of create a false sense of security that well, this is a 7 and this is an 8, so clearly I don't need to pay any attention to the 7s. I'll just pay attention to the 8s, and that's not appropriate. You still need to, so you need to not fall into the trap of assuming that these numerical values are the absolute total story. So you've prioritized the risks, and then you then have to allocate your resources. Again, this is can be physical resources, gloves, hard-toed shoes, hard hats, and things like that. But then other resources are time and energy to construct the fall protection barriers, time and energy for you to go out there on the job in the morning and check to see that everybody is properly suited up and has the right tools, and then perhaps inspecting during the course of the activity to assure that everybody's doing what they're supposed to be doing. So anyway, the activity hazard analysis process has been developed largely out of the OSHA business as a way of implementing a risk management process for construction projects. And this is a key piece of paper that has been developed that is part of the activity hazard analysis process with federal agencies, and increasingly with other public agencies, state and local, and private companies. And what it does is it distills down this contractor risk assessment project into what is called these days a construction activity hazard analysis. And this is a key piece of paper that is used. And this is what the construction manager and the construction supervisor use as a key tool in planning a risk assessment program, a risk management program for a specific job that you've got coming down the line. This piece of paper here, it varies a little bit depending upon agencies and companies that happen to be using it, but they all pretty much look fairly similar like this. So the this is a piece of paper that you, the construction manager, the construction supervisor fills out, if you will, at the start of a particular construction activity. Now, in looking at a particular construction project, you actually start out, one way of looking at it, by identifying defined features of work. This is just some of the wording that is used. So let's take a simple project. You're building a house, and a defined feature of work is the site grading, as an example. The trenching for the foundations and the utilities, another defined feature of the work. Construction of the foundations for the building, the setting of the forms for the concrete, pouring of the concrete, setting of the metal devices in the foundation walls, etc., etc. Similarly with the utilities, trenching, placing the utilities in the trench, covering them, etc., etc., etc. So there are various, and then there you go through the whole process with whatever your project is. If this, in this example, this illustration, a simple residential house, the foundation is a defined feature of the work. The framing is a defined feature of the work. The bringing the utilities, the mechanical utilities to the house is a defined feature of the work. Bringing the electrical utilities to the house is a defined feature of the work. And roofing is a defined feature of the work, roof framing, roofing. And then on through the whole process, the interior, the HVAC system, the interior plumbing, the interior electrical distribution, the insulation work, the gypboard, and so on and so forth. And these are all defined features of the work. And you can kind of get a leg up, if you will, on identifying the defined features of the work by looking at the typical construction schedule. And you've probably all seen these plenty of times. I mean, you know, it's a bar chart and it shows first thing you do is you go out and you grade the site, and second thing you do, you know, you can't start building the foundations until you get the site graded, and on like that. And the typical construction project does a pretty good construction project schedule, does a pretty good job of defining the features of the work for you. And these, to a degree, on the typical project, represent the the work of different subcontractors. So site grading is one subcontractor. He's probably also going to do the trenching, setting of the forms, pouring the concrete for the foundations. That's another subcontractor. And so of course, this schedule tells you when the plumbing contractor needs to be on the job site, how long he's allocated, what length of time he's allocated to get the plumbing work done, and all that sort of thing. So you identify the defined features of the work. And for each feature of the work, then you can define tasks. And that's where this form starts coming into play. You see up there in the upper left-hand corner, there's a box that says activity work task. This is a work task that is needed in order to get something done to complete the construction of a defined feature of the work. This is the defined feature of the work is the foundation for the house, a task that is necessary in order to construct that defined feature of the work is to trench for the foundations. That's one task or activity. Another task or activity associated with that defined feature of work is constructing the forms. Another task or activity is pouring the concrete, et cetera, et cetera, et cetera. So for each defined feature of work, there are a number of tasks or activities that are required to get things done. And so you need to identify those. And this is where the construction manager, construction supervisor begins the thinking process ahead of the beginning of the initiation of the construction work. So that's where this form comes into play. And this is, excuse me, this is a tool that you use. Now, after this form is filled out, completed, it then becomes a tool for use in the construction process. It's used to guide the construction supervisor on the job site and the workers all involved in a particular task or activity need to have a copy of this so that they know what they need to think about from the standpoint of safety. So we're constructing the foundations for this house. One of the tasks is trenching for the foundations. That is a task. So that's what you indicate up there in the upper left-hand corner. Now, a quick point. This form varies a bit from federal agency to federal agency just because of the way federal agencies are and because of the differences in their design and construction programs. Like the Veterans Administration, they're very much focused on obviously hospitals and medical facilities and this sort of thing. So they have modified this form to suit the business that they are in. Little different than, say, the Corps of Engineers with flood control types of projects or military types of projects. But generally speaking, this form follows the same sequence of steps and looks pretty similar for different federal agencies. And as this process has been adopted by state and local agencies and private companies, this form, the activity hazard analysis form, looks pretty similar. So you're filling this out. You're the construction supervisor. You've identified a task, the project location, that obviously wherever it is, contract number, and then for each task there are job steps, things that need to be done by the workers in the field. And this is where, on this version of this form, this begins to you begin filling in these steps, and the individual steps that are necessary to undertake and complete this particular task. And obviously you can get into a lot of detail here, but there's a step, hammering nails. You're constructing the formwork for the foundations for the house that you are building. And there are steps that you take, hammering nails to join together the pieces of lumber to form the forms for the concrete work. That is a step. And then so that's, you fill in all of the steps where you see on this particular form. Down towards the bottom, you start filling in those job steps. And for each one of those steps, there are potential hazards associated with them. You're hammering nails to join together pieces of lumber to form the formwork for the foundations. Hazards, hitting your thumb with the hammer. Now I'm being a little silly, obviously, but this is to illustrate the concept. So hazards, hitting your thumb with the hammer, dropping the hammer on your toe, perhaps stumbling over some formwork, partially completed formwork. In any event, with each job step, you need to think about what are the hazards associated with this step. And then the third column from the left down there towards the bottom is controls. How do you prevent someone from hitting their thumb with a hammer and injuring their thumb? Well, one control you might say is wearing heavy work gloves, and there are all sorts of things that you can think about. But this is the process of your thinking, and then the last column on the right there, RAC. That is a term for the risk assessment code. In other words, this is the priority that you assign to that particular job step and its hazards and the controls that you need to apply to that job step. And this is the combination of your assessment of the likelihood that this incident in risk will occur, and then the severity of the injury that may result as a result of the this risk, this hazard, this incident materializing. So this is your judgment of the combined risk of the hazard occurring, and then the severity of it occurring. And this is completely a professional judgment on your part. Now, a little bit earlier, I talked in terms of a point system, 1 to 10 for potential for the incident to occur, 1 to 10 for the severity of the injury if it does occur. And then you combine those two and you come up with a numerical rating 1 to 10. Well, because this is, you don't want to fall into the trap of attaching too much significance to these numbers. Is a 7 really that much more serious than a 6, et cetera, et cetera? This activity hazard analysis process has been developed with simplified categories of extremely high risk, moderate risk, and low risk. And these are indicated on this by the colors on this kind of relatively standardized form. And so for this particular, for the job step, you assign a risk assessment code to that job step. And it, so job step number 1, you, using your judgment and the thought process that you've gone through, you assign it a high risk rating. And you just, in column 4 on the right, you enter H for this is a high risk job step. The next job step, whatever it is, you make a judgment that it is a low risk job step. And you go through all of the job steps, and for each one of them, after you've gone through this thought process, what is the job step? What are the hazards associated with the job step? What are the controls we can use to reduce or minimize these hazards? And then after these controls, when these controls are implemented on the job site, what is my judgment of the risk assessment code for this job step? Go through that with all of the job steps, and then usually, and you'll see some examples of this kind of a form in a few minutes, you assign an overall risk assessment code to the task. So the specific task has a lot of job steps in it, and they have different risk assessment codes ranging from low risk to extremely high risk. And you look at those and you make a judgment what the overall risk assessment code should be for this task overall. Now, this particular form, they do not have a space for that overall risk assessment code for the task. You'll see some example forms a little bit later that do have a box where you fill in the risk assessment code for the overall task. So what you end up with is all of these tasks, and they have different risk assessment codes. You've gone through this thinking process before you start on the job. And so now you've developed a list of priorities, if you will, because you want to devote your time and energy and money to those riskiest tasks, and those are now defined for you. Okay, now we have come to the point where we need to take our first 10-minute break. I've got 10 minutes before the hour, so let's come back in 10 minutes on the hour and we'll finish up here. So let's do that now. Let's take a 10-minute break and come back on the hour. Okay, this is Paul Guyer, and I'm back. Okay, let's press on with the slides here. Okay, now some of these slides basically are just recapping what I've already kind of said is verbally, that you begin with the defined features of work for the project. The project is a simple residential house construction, and there are the various defined features, the foundations, the framing, etc., etc. That's the starting point for your thinking, you being the construction supervisor or construction manager. And each one of those defined features of work has a certain number of tasks that need to be undertaken to get that defined feature of work built, the foundations. And so you break the defined feature of work down into the tasks or activities, and for each task or activity, it has a number of steps. So that's the next level down, if you will, defining the steps that need to be taken. And each one of those steps, there are risks associated with it. There are there is the risk or probability that it will occur, an accident will occur, and then there is the risk or probability that the injury will be serious or not so serious. You make a judgment using your professional judgment as to what the combined risk of those two aspects of that hazard are, and come up with a risk assessment code. That's the way this process is set up. Now, there is another concept that is introduced in this activity hazard analysis process, and this is the concept of a competent person, and then they've also defined the term qualified person. The short definition of either one of these is somebody who knows what they're doing. I'm not fully versed in what each agency, how each agency defines competent person or qualified person. But the short answer is that whatever name you attach to this person, it's somebody that knows what they're doing. Now, as I look at these terms, I would tend to say that probably qualified person means it's someone who has gone through a certain amount of formalized training, like welding. Welders get trained and tested in certain procedures. And so that would be a qualified person in that particular welding activity, because he has this certification as a qualified welder or qualified on certain types of welds. A competent person is just kind of a guy that's got a lot of field experience, and he just knows what he's doing. And this is an important actor in this process, and the way this is accommodated in the activity hazard analysis is that on most versions of this form, there is a place on the form, and you will see this later here on some of the forms, to enter the name of a competent person or qualified person. So you've got a specific step that you're taking or task that you're taking, and you have identified the risks associated, and you have identified the controls that you need to use to prevent accidents with that step. And then there is a space, who is a competent person that knows what they're doing as far as this particular step is concerned. So this is gives the worker a tool, and again, emphasizing that this form needs to be in the hands of all of the workers on the job site who are involved in a certain tasks, so that they see we're now moving to this step in the task, and what are the hazards, and what are the controls, the protective equipment that I need to have, and then who knows what they're doing on this particular task, either a competent person or a qualified person. So that's important, and that is a piece of information that is entered on this form. Now, in general, the activity hazard analysis needs to be prepared by the construction manager or construction supervisor, and then submitted to the owner for approval. And that's approval, and more in the real world, the approval that's probably needed is his insurance, the owner's insurance company, workers' comp insurance or liability insurance, this sort of thing. And the owner takes the activity hazard analysis that you have prepared, submits them to the insurance carrier, and the insurance company says, okay, you've thought this through, go ahead with the project and we'll cover you, or no, you haven't thought this the risks through on this project, so go back to the drawing board, if you will, as far as worker safety is concerned. So the insurance company, from the perspective of your company or agency, a very key actor in this process is the insurance company. Okay, so the activity hazard analysis form is completed. The construction manager, construction supervisor uses it as a tool to guide what he does in the field, the tasks he needs to go out and inspect before they're begun, in the process of their being undertaken, the protective equipment's needed, all this sort of thing. Hang on just a second here. I need to play with my controls just a little bit. Okay. So let's keep moving with the slides here. Now, another point, and I mentioned this early on, is that this activity hazard analysis form, piece of paper, is a living document that as the work progresses, typically the construction supervisor may say, oh geez, we didn't recognize at the beginning that there was this additional risk associated with this task, and so I need to modify this piece of paper, this activity hazard analysis piece of paper. And so he does that, and it's intended to be a living document that is modified as you move forward with the project, and you learn from the project that oh, there are these different risks that need to be taken into account with this step in this task. So it's a living document, and again, the importance of so the document gets revised during the project, and then the importance that the workers on the job have a copy of the latest version of the activity hazard analysis. So when they're drinking coffee first thing in the morning, they can look it over and say, oh yes, I need to watch out for this today. Or I don't have this protective equipment that I'm supposed to have. So this is a tool for the workers on the job to use. And then the last point to keep in mind is the value of this document as an archival resource for your company or agency. This is the project, this kind of project we undertook to build a house. And these are the activity hazard analyses that were prepared for this project. We modified them as the work moved forward. The house got built, no serious injuries, etc. So that goes into the archives. And the next time your company has a house construction project that comes along, the owner can go to the archive, the owner or the construction manager or the construction supervisor can go to these archival copies of the activity hazard analysis forms and use them to prepare the activity hazard analysis forms for this new project that's coming up. Okay, we touched on that. Now we're going to start looking at the preparation of this form as a 6-step process. So this is kind of the guideline for you. I'm kind of assuming that most of you are in some way associated with the construction end of things as compared to design, but maybe not. And it's certainly very helpful for designers to understand what the construction people are dealing with. So here is a different version of this particular form. Upper left-hand corner, you have the activity or work task. Again, this is a subset of the defined feature of the work. The defined feature of the work in the construction schedule is construction of the foundation. An activity or task is trenching for the foundation, etc., etc., etc. And then for each one of the tasks, you have a series of steps, that work steps. And each one of those steps has certain hazards associated with it. And then you document on this form the controls that you need to have in place to minimize the risks of an injury when this job step is being undertaken. So the controls might be wear hard-toed shoes, wear knee pads, wear a hard hat. Another control might be procedural. Construction supervisor shall inspect the crew in the morning to make sure that they've got everything that they need. And then the risk assessment code that you assign to that particular job step. And this helps you focus, everybody to focus on the hazards associated with the different steps. And then this particular form, unlike the other one that we saw, this one does have a place in the upper right-hand corner to enter an overall risk assessment code for this specific activity or work task. So the job steps have a risk assessment code, extreme, high, medium, low, and then the work task has an overall code. And again, this is intended to help you and the workers on the job to focus on where the hazards are. So this is another version of the form, and also this version has some additional bits of information that are called for in this bottom band of boxes. Equipment to be used, and you name it. It can be personal protective equipment. It can be protective equipment for equipment, shielding for welding work, etc., etc. And then training. Say welding's involved. Does a worker on this particular task need to have any particular training to weld with a welder, as an example? Yes, the welder needs to be trained and have such and such certification for such and such type of weld. And so the training that is required by persons who are working on this particular task is identified in that center column. And then on the right hand box, lower right hand corner, inspection requirements. Construction superintendent needs to go out in the morning and check and see that everybody's got their hard-toed shoes on, and their knee pads, and their hard hats, and their reflective jackets, etc., etc., all that sort of thing. And so inspections can be both initial inspections, and then you figure everything's okay, or maybe this is of such a hazardous potential that there need to be periodic re-inspections. Go out at noon and see that things are going smoothly. So getting back here on the track of this 6-step process, and again, as we've already talked through here, the activity hazard analysis defines the activities being performed and identifies the work sequences, the specific anticipated hazards, both the potential that an incident will arise, and then the severity of the incident if it does arise, and the site conditions, any things that about the particular job site that make it more hazardous. The ground is sloping, things like that. Materials that are being used, are some of them hazardous? They can burn your skin if you get them on your skin. The fumes are hazardous, etc., etc. And then the control measures that need to be put in place. And the control measures can be personal protective equipment, they can be procedural, they can be inspections, and those are all spelled out. And generally speaking, the way things should work is that after the construction manager or supervisor has prepared the activity hazard analyses for a project, they need to be submitted to the owner, and the owner will most likely sit down with his insurance carrier and go over them. And so that both the owner and the insurance carrier see how the construction supervisor or manager viewed the project, and they may have some insights that they're concerned about because obviously they have significant financial stake in it. Also on the form, which you have not yet seen a version of this form that has a place to enter these names, but it's a very helpful piece of information for everyone to have readily available, and that is for the various job steps, a name and phone number of a specific competent or qualified person. So a worker on the site says, I don't know what I'm supposed to be doing here. Let's see, here's the guy that's supposed to, the competent person. I'll give him a call or walk over and talk to him about this. So it's, that's a very important piece of information to have on this form. And then the other point that I've touched on already a couple times is that the activity hazard analysis forms are a living document. As you're going through the project, you become aware that there are additional steps or additional hazards that you didn't think about up front. And so you go through a simple revision process, update the activity hazard analysis sheet for this step, maybe get the owner and to sign off on them, and then you distribute them to all of the players out there in the field, the workers. So the 6-step process consists of these 6 steps. Identifying the definable features of the work, and the project schedule is usually a pretty good starting point for this. We start the foundation work on this date, ended on this date. That is a defined feature of the work, the foundations. What are the hazards? And the hazards are defined in in the framework of the tasks and the steps. So the defined feature of work is at the top. That is broken down into tasks, and then each task is broken down into steps. And it's for each one of those steps that you identify the hazards, the controls, equipment, inspections, procedures, and you identify the competent, qualified person, the person that knows what he's doing, he or she, knows what he or she is doing, so that the worker who is using this as a tool out there in the field can look at this and say, I don't know what I'm doing on this particular job step, so I'll go find the competent or qualified person and ask him or her what I'm supposed to be doing. And then each task is, or each step is a risk assessment code. And then it is a good idea, as I indicated, not all of the versions of this form necessarily have this feature printed on them, but I think that it's a good approach then to blend together the risk assessment codes for the individual job steps into a single risk assessment code for the task. It just helps everybody to focus their thinking. These are the potentially hazardous tasks, and so we need to pay attention. And then the form in its best iteration needs to identify for each step the equipment that's needed, personal equipment, operational equipment, et cetera, any special training that the workers require, certified welders, et cetera, electrical safety training, things like that. And then inspections that the construction supervisor, construction manager needs to perform. So the first step in this 6-step process is to look at the definable features of the work. There may be a contractor quality control plan. If this is a federal contract, that's pretty much a standard feature spelled out in the specifications and in the contract between the contractor and the federal government, the federal agency. So that is something that you look at to determine the defined features of the work. Then the contract project schedule is an important clue as to what are the definable features of the work. And then the within each definable feature of the work are the tasks that need to be undertaken. Setup of the construction office trailers, staging of construction materials, where the borrow material is to be stored, where the lumber is to be stored, where the waste material is to be dumped, etc., etc. Demolition work, another task, and then if there's asbestos and lead and all of that stuff. So the in this first step, the definable features of work, a good clue as to what they are is the construction schedule. And here you see the typical bar chart construction schedule. And these come pretty close to defining the features of the work. And then for each definable feature of work, there is a task. Now, it could be that a definable feature of work can be considered to be an activity or work task that you would fill in at the in that upper left-hand corner there. But it's also conceivable that a definable feature of work clearly has a number of different tasks that need to be accomplished, and therefore in the upper left-hand corner would be the work task that you have identified, which is necessary to complete the construction of the definable feature of work. This is a judgment call on how you use this kind of a form. The key as far as the activity hazard analysis, though, is the job steps that you identify. These are the steps that are necessary in order to complete this work task. And this work task needs to be completed in order to achieve the construction of the defined feature of work. And it's each of these job steps. This is where you really begin to focus on safety, and that is identifying the hazards, drop the hammer on your toe, bang your thumb with the hammer when you're pounding nails, somebody drops a brick that could hit you on the head, And so there are all of these hazards associated with a job step. And what are the controls that you can put in place to mitigate or try to minimize or avoid one of these hazard incidents from occurring? And the controls, again, they can be appropriate equipment, and they can also be procedures and that sort of thing. So, and then for each of the job steps, you need to make a judgment decision about what should be the risk assessment code. Extreme, high, moderate, low, using the little color chart there. And, oh, and you see that the color chart up there blends together the severity and probability aspects that you need to think about in terms of a risk assessment code. So severity of it happening, catastrophic is the worst, critical, then marginal, then negligible. Moving down the line. And then probability, the probability is that it will frequently occur, likely occur, occasionally occur, seldom occur, unlikely to occur. And this, you make your judgments on those two scales, severity and probability, and you look at the color chart and you decide, yes, this is red, so that's extreme, and so that's what you enter in the risk assessment code box for the steps, and then also the overall risk assessment code in the upper right-hand corner for the overall activity or work task. So definable features of work is the starting point. And then what are the hazards? Identify the hazards. And this illustrates with some typical questions that you can ask yourself. Is there a danger of the employee being struck by something, falling objects, moving equipment, et cetera, et cetera? Now, this is the first illustration here of what I characterize as a checklist, and there are some further on. And this raises an important point, I think, in my mind, is the importance of checklists, because we can't remember everything. We always forget things. That's just human nature. But checklists are a very useful and effective tool to prevent things from being overlooked. If you remember, those of you who were around in those days, the you know, when the astronauts first started going into space, you'd see these television programs where they were running through their checklists and this sort of thing. And on an airliner, when the pilot and the co-pilot get in there and they're starting up, why, they have their checklists and they read right through them. And is the door closed? Yes, no, yes, the door is closed. Things like that. And checklists are very, very helpful in helping you to avoid overlooking things or forgetting things. And so here, this is kind of a checklist: a danger of employees being struck by something. Can the employee slip or trip? Can the employee be caught in between objects? Does the work possibly cause strains or sprains? Is there a risk of electrical shock? Et cetera, et cetera. Can the employee fall? Is there a fall risk? Can the employee come in contact with high high voltage power lines, things like that? Will they be exposed to hazardous chemicals, fumes, et cetera, et cetera? So what are the hazards associated for this particular task or job step, really? And so those hazards are filled in. That's step number 2, is filling in the hazards. And these are some kind of magic words to jog your memory. Struck by la-di-da, fall on such and such, punctured by, caught on, impaled by, electric shock, stung by, et cetera, et cetera. So the hazards for each job step are enumerated in the hazards column. And then step number 3 is the controls, entering what controls, site-specific control measures to eliminate or reduce each hazard to an acceptable risk level. Can the working condition or process be changed? Don't do this work in the rain, things like that. Can the hazard be eliminated with engineering controls? Constructing a shoring for the excavation for the pipeline. What type of PPE can be used? PPE means personal protective equipment. Hard-toed shoes, gloves, knee pads, hard hat, reflective jacket, that sort of thing. Can the hazard be eliminated with administrative controls? The way you go about things, requiring that whoever does this particular piece of work be able to assure the construction superintendent that he or she has previously done this kind of work. What can the employee do to prevent an accident or eliminate the hazard, and so on and so forth. Utilize past experiences, of course. That's why you've got this high-paying job as a construction supervisor or construction manager. You've got a lot of past experience. You've learned from the past. After action reports are a good tool for a company or agency. I pointed to the fact that these activity hazard analysis forms are a good piece of archival information, but after action reports, okay, just the construction superintendent sits down after the project is completed and just writes out, well, this is what we did, that worked pretty well. This is something else we did, didn't work out that well. After action reports. Accident trends, and this is something that you as a construction supervisor or a construction manager may not have immediate access to. What are the trends for injuries in the excavation of trenches for buried pipelines? And is there information available in the commercial and technical literature about what has been happening on other trenching projects across the country? And that can be useful information. Common sense. I mean, that doesn't need any further explanation, but just common sense is very important to what you do on a construction project. And you use all of these to formulate the control measures that you want to spell out on the activity hazard analysis. And the goal is to reduce each hazard to acceptable risk levels. Okay, and then the controls. and here's are some illustrations of controls. The job step is the project field office placement, a hazard being struck by moving equipment. Controls where reflective vests, established no-go zones with flagging or barrier tape, etc., etc., etc. Utilities tie-ins, and so step number 3 is spelling out the controls that you need to apply to each one of these steps which presents a hazardous situation. Step number 4 is identifying the competent or qualified personnel. Remember, this piece of paper is a tool that your workers are going to be using on the job. And so they are told to go over there and do this or that. So they go over there, they take out their activity hazard analysis, and they don't know what to do, or don't know completely what to do. Well, who do I go to find out what I'm supposed to be doing here? And that's spelled out on the activity hazard analysis. That's the name and phone number, if you will, of a competent or qualified person. And examples are excavation work, scaffolding, electrical work, certainly, work in confined spaces, etc., etc. And on the this particular iteration of this form, this form has in that center column training requirements or qualified personnel names. Now this is a pretty good version of this form, I think, because it has space on it to where you can enter what training is required for the workers that are doing this. And then also, if you don't know what you're doing, who do you go talk to? Who's the qualified person? And then inspections required. Construction superintendent needs to go out there and check that everybody's squared away in the morning, check back again after lunch to make sure they're still wearing their protective equipment, etc., etc. And this particular version here of this form, like I say, it has a space for to enter the risk assessment code for each step in this task. And then in the upper right-hand corner is a space to enter the risk assessment code for the overall task. And I like that because it helps you focus your time and energy on the things where there are substantial risks involved. And that brings us to step 5, which is the determination of the risk assessment code. And again, it is a combination of probability and severity of a hazard materializing and there being an incident on the job site. So probability, keep the terminology relatively simple. Be consistent in using the terminology when you talk about things with others and when you write things. Probability, frequently this could occur. It's likely that this could occur. Occasionally this might occur. This is seldom going to occur, and this is unlikely to occur. So that's probability. And then severity, the injury that would be the outcome of an incident, a hazard resulting in an incident. Catastrophic, again, to kind of get you to think in terms of always using the same words, so that everybody on your job and in your company or agency uses the same words, and then there's not these translation problems. Catastrophic, hang on just a second. I want to check something here with my, okay, with my controls here. Okay. So severity. You're determining the risk assessment code, a combination of probability and severity. And so these are, you know, the kinds of things you can be, questions you can be asking yourself, or your thought process. Can an employee fall from an elevated height? What's the probability? Occasional. What's the outcome of an incident? The severity, broken arm, leg, etc. And the standardized form, the construction activity hazard analysis, provides this color-coded matrix to kind of make life easy for you. I mean, not necessarily easy, but that there's a consistency from job to job and among the different people in your agency, company, and with other companies that you work with. And so this little color-coded system, which is pretty, it's sufficiently definitive, but sufficiently general that people can grasp it easily. It's a combination of severity and probability, and you end up using this table to identify the risk assessment code as EHLML, and then the color code that is used. And a point to kind of put in mind is that one of your objectives with controls is you want to try to reduce hazards that are by themselves that are extreme or high risks, but by employing controls you can reduce them to moderate or low. And that's an important point. The risk assessment code is after you have implemented controls, after you have your hard-toed shoes on, your knee pads, your reflective vest, your gloves, your hard hat. Then the risk assessment code is reduced from, say, high to medium. And that's what you want to do with controls, is to reduce the extreme and high job steps to a risk assessment code that is medium or low. And more illustrations here of, you know, a job step, installation of a 200-ton chiller or cooling tower, hazard, loss of load during crane lift, okay, and controls that you put in place. And maybe even after putting the controls in place, you cannot rationally reduce the risk assessment code to low or medium. And that's okay. If that's, you know, this is a high risk step, and we've got these controls we're going to put in place. this equipment we're going to use, these procedures we're going to use. Nevertheless, it's still, in my judgment, a high risk activity. And so that's you're absolutely okay to enter an extreme rating for the risk assessment code. And the equipment training and inspection, and this is not, the space for this is not available on all versions of the activity hazard analysis that I've come across, but it's on some it is, and I think it's quite important. What equipment do you need for this step? What training is needed, and what inspections are needed? So that brings us to the end of our allotted time here, and I hope this is about, let's see, I have a question in Q&A. Now, I'm not real up to speed. Let's see, page 5, work shall not begin until law accepted by the owner. Is this to say the reviewed by entry on the AHA is to contain the owner representative's signature? Yes, that's right. It's reviewed by the owner or the owner's representative. It's not prepared by, but he's looked at it. And this is an important point, and this is drifting off into another kind of a webinar that I do. And there's a fundamental point, I think, in design and construction projects. Force as many sets of eyes as possible to look at all of the relevant documentation on a project and to sign off on it. Not that they approve it, not that they prepared it, but that at least they reviewed it, because as soon as you sign any piece of paper, that's raising a little red flag for our lawyers to sue you. And it forces people to take things seriously. So in the reviewed by, yes, have the owner's representative review it. So that's a good question, Nate. Good question. Okay, let's see. Do I have any? I don't think I've got any more questions in the question box. No. Okay. That, as I say, that brings us to the end of the time that we've got available here. There is more information on these PowerPoints that we did not get a chance to get to today. So you might want to get a set of these from PDH Source. And I'm pretty sure the way you do that is just go to the website, log into your account, follow the instructions, and you should be able to get a copy of the PowerPoints. With that, thank you very much for letting me chat with you. I hope this was a little bit interesting for you and perhaps hopefully a little bit helpful for you. So let me just wish you all to have a nice rest of the day, and thanks a lot. Bye.